Let's look at the periodic table in a slightly different way. What I've done here is I've written out the periodic table and I've represented by dots the number of electrons in the outermost shell. So for hydrogen, 1 electron, helium 2, and then lithium, the outermost shell, the principal quantum level 2, 1 electron, then 2 for beryllium, 3 for boron, etc., all the way across to neon. Now notice when I go down the periodic table then, what's clear is that elements that are on top of each other, that are in the same column, have the same number of outer electrons. These outer electrons we call the valence electrons. They're the electrons that are available for chemical reactions and bonding. And if you have the same number of valence electrons, you'll have the same properties. You'll react the same, you'll bond the same to other atoms. And that's why in the periodic table, elements with similar properties line up because they have similar numbers of valence electrons. So our valence electrons go from 1 to 8 along principal quantum level 2 and from 1 to 8 along principal quantum level 3. And when you get to 8, that's called a full shell. It's a stable octet. These elements at the end are not particularly reactive. Neon and argon have a closed shell, stable octet of electrons. They're not as reactive as their counterparts in the corresponding rows. Same thing with helium. It's a closed shell of 2 electrons. That's the maximum number of electrons in principal quantum level 1. And helium is also not very reactive. But what we're going to look at now is how these valence electrons affect the bonding and the reactions of the elements in the periodic table. In fact, reactions and bonding are the subject of pretty much the rest of Chem 1. And the valence electrons are going to help us understand that.